Thank you for inviting me to speak today. My name is Mark Johnson. I'm a faculty member in material science and engineering. Um, so I've been asked a few questions here about role of research and how that winds up having positive impact on society, particularly how we translate that research. So I guess I'd start out by giving you a little bit of introduction on myself. Over the last 15 years or so, the focus of my work really has been on technology innovation can be used to face a range of future challenges, but in particularly challenges where energy, and that is energy that underlies basically everything in civil society, has increasingly negative impacts on human beings in society. We've got things like increase in temperature, and we've got waste materials and a bunch of sustainability issues that are coming out. I came to this work through having kind of three fundamental issues that I think are true. So before we even get to the research, the question is, where do I believe things are true? And one is that the average temperature of the Earth is rising. It's directly correlated to CO2 levels in the atmosphere. A second, just as important reality is that poverty is real, right? And available energy resources is sort of a foundational factor in every economy of the planet. So if we want to wind up addressing raising the standard of living of people, both in the US and globally, we need to deal with the fact that energy as a resource also is foundational to solving those poverty problems. So you've got a negative and a positive. And then the third issue is that human beings were economic beings, right? You need to have economically efficient ways of delivering those energy services, and particularly things with new technologies in them, to society. So this is really closely aligned with things that are like the 17 UN sustainability goals. But at the end of the day, what I think as a path to solving these wicked problems where you've got conflicting realities is through technology innovation. We've dealt with these sort of problems throughout human history by innovation in materials, energy, and information. So, throughout history, that's how we've dealt with those problems. The need to translate technology into action is how we actually address those problems in society. So I came to this position, and it was sort of a circuitous route. I spent years working in the semiconductor industry to begin with. I'm essentially a semiconductor materials physicist. These semiconductors are really useful in applications like LED-based solid-state lighting and power electronic systems. And this led me into the entire field of clean energy. I've really been lucky to have had three interrelated careers in my life. First was in the private sector, primarily in venture capital-based startups doing things like epitaxial crystal growth for compound semiconductor materials and devices. Quite a mouthful for my investors, but I think in a technical community, it is how do we build the materials that make it possible for the semiconductors that underlie society to work, and understanding how to make that work. Part of that was leveraging the research that was in university and national lab facilities, and spinning those technologies out, working with universities, and both working with the universities and having an ecosystem around the university that was able to accept was receptive to technology spinouts. This led to my second career, though, which is an academic researcher. I began working in a university on advanced semiconductor materials and devices. That work was supported by places like DARPA and the National Science Foundation. At one point in my life, I was a DARPA young investigator a few years back. But as a result of this, what wound up coming to is some of these advanced semiconductor materials became a fundamental science foundation for an engineering research center that the National Science Foundation funded that was really focused on bringing controllable intelligence to future electric grid systems. So those semiconductor materials enable that interface between information systems and energy systems. This led to my third career, and that is as a federal government official. First, I was one of the initial program directors at something called ARPA-E. So that is the DARPA of energy, having been a DARPA young investigator and had expertise in that area. Worked in a lot of new materials, energy storage, rare earth materials, but also really focusing on some of the manufacturing issues on the technologies that would come out of the work at ARPA-E. I must have done a good job at this because I was then asked to become the director of advanced manufacturing for the entire US Department of Energy. It's another story, but when my time ended there, the upstate region of South Carolina became the stage for my next stage of my career, and that's how I wound up at Clemson. And the next question is, strides a comprehensive initiative aimed at enhancing research translation capacity of the university. In your own words, how would you define research translation from market impact perspective? To start by saying, by research translation, I assume you mean research translation from the university into the marketplace. With that in mind, there are really three reasons why a research university like Clemson should have an effective translation and research translation environment. And they are the best places for doing that in society. First is the obvious one that people think of as tech transfer. There are discoveries coming out of the laboratories in a university that can have value in society. Patenting and commercializing those discoveries is a way that universities can advance research from the laboratory and have impact on society. And there needs to be a market for that. It's identifying who's going to buy something, why are they going to buy it, and what's the problem you're solving for them. Now, a second and just as important aspect of tech transfer or translational research in a university environment is that universities really become home to innovators that are outside of our research labs that actually have a market problem they're trying to solve. And the best place for them to solve that market-driven problem is in the ecosystem or around the university itself. You find that at a number of AAU level research universities, like a biotechnology cluster that might pop up around an MIT, or a robotics company that might locate to be next to Carnegie Mellon, because they want to be in those, those research and be adjacent to them. By doing that, companies and researchers in those small startup companies in particular can gain access to further their goals faster. Here at Clemson, we've got a terrific relationship with companies like BMW, who located their own research center on the Clemson ICAR campus. So they've got an information technology research center that is just adjacent to the building where we're educating the next generation of engineers, automotive engineers. We also have things like companies like Tetramer or Polymed that are located in the upstate region in the area, just to be close to things like the AMRL campus, where you've got the resources of everything from having access to unique research tools like electron microscopes, and having that access because they can wind up furthering their goals faster. And while the university doesn't get a direct financial benefit from this co-location, there's a real symbiotic value between the university, because our university really grows what's called its innovation ecosystem as a result. Now, there's a third reason why we want to wind up having better translational research, or why universities have to be very effective at translational research. And this is what's really been the focus of my attention and has me captivated recently. And that is not just how we wind up transferring the technologies out, but transferring the people out from the university so that they move with the technology and wind up advancing it and achieving their own personal hopes and dreams as they're advancing the technology every year. In fact, universities hold celebrations 3 times a year to celebrate this kind of tech transfer, and that's where students wind up putting on special little robes and wind up getting handed pieces of paper and sent out into the world. And in some ways, this is the biggest tech transfer impact of the university. I think an opportunity we have at Clemson here, we're really good at doing that through our partnerships with large companies. I think with Clemson, an area where we can wind up improving that is how are we working with our STEM students to try and do things like lead university-based startups. So how a graduate student working at Clemson, instead of saying, I'm going to go find a job, saying, I'm going to go start a company. Or I'm going to join some colleagues that are starting a company. And so we can wind up advancing technologies that way. And I think that's an area where we really can double down our work and emphasize it even further. One of the main challenges I face in translating research into real-world societal or market applications. Clemson does actually a really good job at the tech transfer of the first two types of tech transfer I was talking about before. We have a tech transfer office, CURF, that has really good processes in place, and then we're following sort of best in practice, best practice approaches to working with companies so that we can wind up taking the research we have and licensing it out. It's a painful process at every university, but CURF does a pretty good job at moving forward on that. Now, can we further the work that we wind up doing and lowering some of the barriers and challenges? Yes, we can always improve our efforts on it, but we've got that structure in place, so that's a good thing. The second kind of tech transfer, though, and that is where we wind up working with companies that are adjacent to our universities, especially large companies. I actually view Clemson as almost best in class at this, particularly through the Vice President of External Affairs Office. We have a formalized process to engage strategic partners that we can wind up doing coordinated strategy of research and education that will benefit the companies in the area, particularly companies in South Carolina. And it's gotten to the point where the Commerce Department in South Carolina actually treats Clemson as part of their recruitment package and partnerships with Clemson as part of their recruitment packages when they're trying to draw foreign direct investment in companies, particularly in sort of manufacturing related companies in the area. So Clemson does a really, really good job of that. The third area, I think, is the area where we got some room to grow. And that is, how do we wind up, especially in STEM-oriented fields, preparing our students not just technically, but how to translate that technology into impact. Just understanding what is the difference between a technology, a product, and a market, and how you can design a value proposition that articulates a product market fit. Those are all teachable activities. And we need to further increase that sort of activity and understanding into our curriculum across the STEM disciplines at Clemson. Okay, next question. Got to ask this. How did I identify strategic directions from our research? What factors influenced your decision to pursue these specific applications for your advanced manufacturing research? So as I shared previously, my specific research focus has evolved over my career. I've been a semiconductor researcher. I've worked on batteries. I've worked on energy storage. I've worked on grid systems, worked on advanced manufacturing activities. I view an intellectual tie throughout the history of that, or my own pathway on it. But it's something where you're able to wind up taking ideas from one area and moving it to the next, to the next, to the next, right? But one of the main reasons I came to Clemson 6 years ago was the excellence in advanced manufacturing across this region. I know it's sometimes hard for people in the area to recognize this, particularly in the wake of the economic downfall, the local economic downfall related to the textile industry. But the upstate region of South Carolina really is ground zero for advanced manufacturing technology in the world. It's one of the best places in the world where that technology is actually seeing impact. I'll say this is more than just unjustified boosterism. If you look at exports per capita for South Carolina, it's the highest in the nation. We're specifically one of the largest exporters of cars, planes, aviation products, and energy systems. This isn't just competing nationally, where South Carolina might compare itself relative to its tax rates or its labor costs relative to Pennsylvania, New York, Michigan, or state of Washington. But this is competing globally, where the use of technology is critical to economic competitiveness. And this is the heart of what is advanced manufacturing. That is where you bring technology to bear, particularly information technology, to wind up driving competitiveness of your manufacturing. And it's fascinating how well South Carolina does this. It integrates in everything from the logistics to the individual materials processes that are being developed, and has a real a cluster of excellence in this area. So what are some of the most significant milestones I've reached in my research in advanced manufacturing? So in my previous role, I led the establishment. This is when I was working for the U.S. government. I led the establishment of 6 public-private partnerships nationally as the foundation for what became the Manufacturing USA Network. I've had the opportunity of working on advanced manufacturing issues with each of the 3 past administrations, as furthering technologies related to advanced manufacturing really is essential to economic growth of the nation. And that is something that is shared by as much dysfunction as there is in DC. Everyone agrees, let's support manufacturing. So it's one of those areas where bringing technology to bear really does have a lot of people that want to see us succeed at this area. Specific to South Carolina, we've had a presence by an investment from companies that are headquartered overseas, where a substantial amount of foreign direct investment into the United States, in particular working with international partners from places like Germany, France, Sweden, Japan. They've all recognized that they put their money to work in South Carolina and across the Southeast US overall. It's actually a really competitive place to do manufacturing. For example, in the automotive industry, the number one exporter of cars, largest automotive exporting factory in the United States is the BMW factory here in the upstate. But that supply chain for materials, parts, supplies, as well as the customers, the 70% of the customers that are receiving cars outside of the US, right? In that case, you've already got products, materials crossing borders. What this also means in advanced manufacturing is that the data related to manufacturing these products is also crossing borders. This opens a real challenge when we're concerned about things like cybersecurity, interoperability, resilience, and sustainability in a manufacturing supply chain. One thing I'm particularly pleased about that I've worked on in the last couple of years, something called the International Manufacturing Acts Council. This is an organization with representatives from 11 nations. All these nations are democracies like the US, very, very similar. It was originally organized by a group out of the German government, but really is the Germans, the French, the Spanish, Canadians, Japanese, Korean representatives, Australian representatives that are all interested in the issue of manufacturing and also data interoperability and security of that data as it moves across borders. So I'm one of 4 people from the US on the International Manufacturing Acts Council, and we've really sort of established that group over the last 3 years. And the entire purpose is to coordinate between, and it's not just governments, it's companies, it's public-private partnerships, it's universities, to wind up communicating to make sure that the technical solutions that are being developed on the supply chain information winds up being interoperable so that it's secure and safe in working across these international domains, as we want to be as competitive as possible. Describe some key breakthroughs in your development of advanced manufacturing research. I'll say I had 2 things I could talk about in my own research that have been some key breakthroughs. One was worked a lot, this is a few years back, on some materials called wide bandgap semiconductors and how you can actually grow the semiconductor crystals for that. When I was in graduate school, the very first blue laser in the United States came out of the lab that I was in. Jeff Brown and I got PhDs out of it. It was the second blue laser in the world. The first one was in Japan. Tsuji Nakamura got a Nobel Prize out of that. So, that was sort of cutting edge research that we were able to wind up working on. I think as I move forward, I think one of the areas that I'm keenly interested in is this idea of connectivity between impact of the research and the actual fundamental discoveries themselves. So how can you wind up working on things that not only have academic interest in them, but also wind up becoming of commercial benefit? And working together with a number of groups on it. I think I described some of the work we wound up doing on interoperability and data interoperability. Did a lot of work on 3D printing. This is 5-6 years ago, where we were able to actually 3D print entire cars. So designing and building the 3D printers. This was working with some national labs on these issues. An area right now that I think is very interesting is sustainability, particularly looking at sustainable information-based sustainability. How we can worry about things like, how do I develop a new plastic that makes it so we can reduce the amount of plastic in landfills and that running off into the ocean and impacting society. It's another whole thing to say, okay, my innovation, the thing I did, how will it concretely make a change in this? I think that's a really big challenge we can wind up working on right now. How did you approach difficult decisions during your research process? Can you walk us through a decision-making process? Well, I think the first decision-making process that whenever I'm working in an area, because you're going to be spending a good bit of your time working on this, is if this works, will it matter? Will this just generate some papers for you? And that's good. That's a great advancement of knowledge for humanity. And that's one way things matter. But by going through and breaking down the question of how is that problem solved today and how this technology winds up changing how people will solve this problem in the future is really, a good way to help drive where you spend your time in doing your research, right? You do this by running your numbers. You don't know the answers up in advance, but you at least develop a model for what success winds up looking like. And then you validate relative to that model. You build not only the work you're doing, but you build a community of people interested in it so that then you can wind up ultimately having this make it to the marketplace. And the last question, what advice would you give other researchers looking to translate research into practical applications? I think that there are, in a university, two sets of researchers working in the area that can potentially translate research into the marketplace. One are faculty members, and faculty members are already working on their day job. They are faculty members because they spent their career wanting to become faculty members. So it's not necessarily the best use of our time as society of saying, we're just going to turn you into an entrepreneur now. I think the best example of this in my career was working with someone on my own thesis committee, Bob Davis. He's now at Carnegie Mellon, recently retired. That I think there's 4 or 5 companies that have spun out of his labs over the years. Not a single one of them was he active in. And not because he wasn't interested in it. As that he said, I'm a researcher, I run research labs. So figure out what you want to do. Now, at the same time, your students come through, and only like 20% of people that even get PhDs ultimately join academia. Far more people wind up coming through and they go into the private sector. They go into a bunch of other fields, banking or whatever it is that out of think of your own classmates when you're in a PhD, where did they wind up? But a substantial number of them want to start companies. And this will be their full-time job. If they wind up going into starting a company, this is what they do. So I think the first question when you translate research into practical application is that decision of what role do you want to do? What's your life going to look like? And if you say, I need this to translate, I know I need to translate, but I'm not the person to wind up doing it, coming to that realistic decision and say, that means I need to identify some of my grad students, some of my postdocs, you name it, the people around you, and very early on, empower them, just as you're empowering them with knowledge in doing their research, empower them to work with Kerf to spin out a technology if they need to learn what are the skills in how to do entrepreneurial spinouts. Treat this as part of their educational experience. And when then they're successful, you'll be successful as a result of it. So, do you want to be in that company or not? Especially if you're looking at translating through a startup.